Okay, students, let us move to the first question. Question number 26. It is like this. If lambda and k are de Broglie wavelength and kinetic energy respectively of a particle with constant mass, the correct graphical representation for the particle will be. See, we knew the kinetic energy formula k equal to half m v square, right? And we knew the relation between E equal to hc by lambda, or we will use in this question h by momentum equal to lambda, which is de Broglie's wavelength relation. So what I am doing here is 2k into m equal to mv whole square, right? So I am substituting mv from here. So we will get 2km equal to mv means h by lambda whole square. So I am interchanging these two. So lambda square equal to h square by 2m into 1 by k. Why I am doing like this? Because the options are in 1 by k and in lambda terms. So if you observe here, it is in the form of 1 by k equal to 2m by h square to lambda square. It is in the form of y equal to 4ax square, because in x-axis we have lambda and in y-axis we have 1 by k. So we knew the graph of this, right? Y equal to 4x square, which is in option number 1. Okay, so let us move to the next question. It is a matching type question. So here you can observe option A, electric field inside a uniformly charged spherical shell with surface charge density sigma and radius r. Everyone knew that for a uniformly charged spherical shell, inside V is constant. Okay, that means electric field should be 0 for it. So for option A, electric field will be 0. Option 3. Next, electric field at a distance r greater than 0 from a uniformly charged infinite plane sheet with surface charge density sigma. It's a direct question, that is sigma by 2 epsilon naught, option 2. And next, C, electric field outside of a uniformly charged spherical shell with surface charge density sigma and radius r. Same, surface charge density sigma and this having radius r. See, electric field outside, right? E equal to kq upon something at a distance r from center. What is k? 1 by 4 pi epsilon naught. Q is sigma into 4 pi r square upon, this is, sorry, kq by r square by r square. So you will be left with sigma by epsilon naught r square into r square, but there is no option. Okay, we will see further and let us see. For option D, electric field between two oppositely charged infinite plane parallel sheets with uniform charge density sigma. See, for a positive plate, electric field, this side and that side will be, it will be away from it, sigma by 2 epsilon naught here, sigma by 2 epsilon naught here. And for a negative plate, it will be towards that plate. For here, sigma by 2 epsilon naught, and due to this, at this point, sigma by 2 epsilon naught, sorry, this side. So they are asking in between and at this point. That means both are will be added, and we will eventually get sigma by epsilon naught. So option A 3, option B 2, option C there is no option, and option D 1. So we are having nearly option number 3 as correct. Okay, let us move to the next problem. Question number 28. The pair of physical quantities not having same dimensions is. So first one is angular momentum. We are having formula L equal to mvr. So its dimension constant. Mass, velocity Lt inverse, radius L, m L square T minus 1. Planck's constant H. So E equal to hc by lambda, right? Or you can also use this lambda equal to h by momentum mv. H equal to mv lambda. See, here also same. Mass, velocity both are same. Radius and lambda, if you observe, lambda is wavelength. It is also in meters, it is also in meters. So these both are having same dimensions. Next, option B. Pressure and Young's modulus. See, pressure is having force by area, Newton meter minus 2. Young's modulus is also same thing, right? Because y equal to F by mg by delta L by L, right? Or in case if you have any doubt, you can also observe this thing. This is ratio, it will get cancelled, and F by mg, sorry, this is not mg, this is a, this is ratio, so it doesn't have any dimension. So it is also same, having same dimensions as pressure. So option B is also correct. I mean, both are having same dimensions, but he was asking not having same dimensions. So let us move to option C. Torque and energy. We have torque formulas R cross F, and energy or work done both are having same formulas. It is F dot R. So in case if you observe, this is cross product, this is dot product, but they are having same dimensions. So let us move to option D. Surface tension and impulse. See, surface tension S equal to F by L, but impulse I equal to F dot delta T. So they are not having same dimensions, but he was asking that thing. So option 4 is correct. Okay. So the next question is question number 39. Let u and v be the distance of object and image from a lens of focal length f. The curved graphical representation of u and v for a convex lens when mod u greater than f. So he was specifically asking for a convex lens, and that too when mod u is greater than f. So let us see this. See, I rather calculate these instead of ray diagrams as magnification m equal to f by f minus u. It will be very useful for you. You can do these calculations in mind itself. Suppose we all knew that when u is minus infinity, rays are coming from infinity, the image will be formed at focus. Suppose u is minus 2f, मतलब अगर if you substitute here u as minus 2f, what will happen? Okay, this is f plus u. F by u is minus 2f and plus f minus f, we are getting minus 1. So here minus represents inverted and 1 represents the size of image with respect to object. Obviously we knew that is magnification. So u equal to minus 2f, v will be 2f. At the same time u equal to minus f, b equal to infinity. So if you observe carefully these relations, you can understand that when the image, okay, when the object is getting closer to the focus, it is going more to the infinity. So from these graphs, if mod u is increasing, mod u is decreasing from right to left, mod v will be what happens? What happens to v? It will increase. So definitely it should follow what? This type of parabola path. So the option number 3 is correct answer. Okay, right. So the next question is question number 30. It was like this. Consider I1 and I2 are the currents flowing simultaneously in two inner nearby coils 1 and 2 respectively. If L1 equal to self-inductance of coil 1, M12 equal to mutual inductance of coil 1 with respect to 2, then the value of induced EMF in coil 1 will be. Okay, we suppose, let us take this one like this. This is a coil 1, and we are having, okay, this is coil 2, let us take, and we are having a coil 1 like this, like this. So both of these are having mutual inductance M12 and it is having self-inductance L1. So they are asking the induced EMF in this coil 1. See, current I1 is flowing in L1 and current I2 is flowing in L2. So induced EMF in coil 1 will be minus L1 di1 by dt, change in current per time, minus M12. So here you may have confusion between d1 by dt or d2 by dt, because it is self-induced, induced EMF in coil 1. You should take I2 because you have already taken mutual inductance of coil 1 with respect to coil 2. So M12 di2 by dt, because with respect to coil 2, right, and the current flowing in coil 2 is I2. Okay, so the option will be option number 4. Okay, so the next question is a direct question, question number 31. It is a assertion type question. So assertion says electromagnetic waves carry energy but not momentum. Is it correct? EM waves carry energy but not momentum? No, the assertion is wrong. They also carry momentum. So the reason was mass of a photon is 0. See, the mass of a photon is 0, that is true. But what's the relation between photon and electromagnetic waves? They are not even related. So the next question, question number 32, is like this. A coil of area A and n turns is rotating with angular velocity omega in a uniform magnetic field B bar about an axis perpendicular to B bar. Magnetic flux phi and induced EMF E across it at an instant when B bar is parallel to plane of coil R. So it is a very basic question. We all knew this thing. Suppose this is a rectangular coil, I'm assuming. It is rotating with angular velocity omega. So let us suppose the magnetic field B bar is in negative z direction. Okay. So it is having n turns and area A. Right. Suppose this axis is in x direction, because he told that axis is perpendicular to B bar. So we knew the formula for magnetic flux, right, which is P bar dot A bar. Okay, I am assuming that it is rotating with the angular velocity omega, and I am writing flux as BA cos omega t, because since the coil is rotating, its area vector also rotates with it. And we also knew the formula for induced EMF E equal to minus N into d phi by dt. So minus N into B into A into cos omega t differentiation, omega into cos differentiation minus sin omega t. So we will be having induced EMF as NAB omega sin omega t. He was asking at an instant when B bar is parallel to plane of coil. When B bar is parallel to plane of coil or 90 degrees. See, I'm sorry. Area vector will be perpendicular to B bar, right? See, suppose this paper is in coil plane, then B bar also will be parallel to this coil, right? That means area vector is perpendicular to the B bar. So the omega t will be 90 degrees or pi by 2. So the induced phi will be 0 at that instant. And at the same time, E equal to NAB omega, because sine pi by 2 is 1. So it is in option 4. So option 4 is correct. Okay. So let us move to next question, that is question number 33. Two projectiles are fired with same initial speed from same point on ground at angles of 45 degrees minus alpha and 45 degrees plus alpha respectively. With the horizontal direction, the ratio of their maximum height attained they are asking. So according to question, we have something like this. A body is projected with 45 minus alpha degrees and another body is projected with 45 plus alpha degrees, right? So we knew the formula for maximum height. What is the formula for maximum height? H max equal to Vy square upon 2g. Vy is vertical velocity. So what will be the vertical velocity component? That is total velocity into cos theta whole square upon 2g. So for the first body, h1 will be v square cos 45 minus alpha whole square upon 2g divided by h2 will be v square cos 45 plus alpha whole square upon 2g. So when we do calculation, we will be having h1 upon h2 equal to cos 45 cos alpha plus sin 45 sin alpha upon cos 45 cos alpha minus sin 45 sin alpha. We knew that cos 45 equal to sin 45, so they will be cancelled out and we will be having cos alpha plus sin alpha upon cos alpha minus sin alpha. So but the options are in the form of sin 2 alpha and tan alpha. So we knew that yeah, sorry, I have forgotten to square. So cos alpha plus sin alpha whole square equal to cos square alpha plus sin square alpha plus 2 into sin alpha cos alpha, which is 1 plus sin 2 alpha, and cos alpha minus sin alpha whole square equal to cos square alpha plus sin square alpha minus 2 sin alpha cos alpha, which is 1 minus sin 2 alpha. So the correct option will be option number 1. So the next question, question number 34 is, the work done in an adiabatic change in an ideal gas depends upon only. So what is general form of an adiabatic matlab or ideal gas? How it will be? PV power gamma equal to something constant K. Am I right? So we also knew the formula for work done, that is minus P dV. from 1 to 2 because it is a path function. So work done in adiabatic change in an ideal gas. So I can write this P as minus K upon V gamma dV. So there will be integration from path 1 to path 2, V1 to V2. So we knew the integration for V power minus gamma, that is V power minus gamma plus 1 upon minus gamma plus 1 V1 to V2. So let us substitute V1 and V2 in this. We are having K upon 1 minus gamma into V power V2 into, so we knew V power minus gamma into K equal to P, right? So instead of writing K into V power minus gamma, I am writing here P2 minus V1. At the same way, it is P1. So K will be not there because K into V power minus gamma is P, right? So here you can observe that P1 V1 minus P2 V2 by gamma minus 1 is work done for an adiabatic change in an ideal gas, right? So it is an ideal gas, so it is obviously obeying the ideal gas equation, which is PV equal to nRT. So instead of writing P1 V1, I am writing nR T1 and P2 V2, I am writing nR T2 by gamma minus 1. So according to this, let us answer this question. So the options are change in its pressure, no. Change in its temperature, yes, obviously. Change in its specific heat, no. There is no specific heat in this. Change in its volume, no. So the correct option is change in its temperature, which is option number 2. Okay. So let us move to the next question, which is question number 35. So it is a assertion reason type question, in which assertion is emission of electrons in photoelectric effect can be suppressed by applying a sufficiently negative electron potential to the photoemissive substance. So basically what he is telling is, if there is any metal and if we are emitting light on it, so the electrons will be emitted right from it. So he was telling that emission of electrons in photoelectric effect, and this effect is called photoelectric effect, right? We all knew that thing. So can be suppressed by applying a sufficiently negative electron potential to the photoemissive substance. So if we apply some negative electron potential for this, then the electron emission will be stopped. Why? Because we are giving energy in the form of photon. Photon is giving in the energy for the electrons, h nu, that is converting into work function. This is h nu naught plus kinetic energy, and this kinetic energy can be written as into something potential V, because it's electron, right? Q into E. So Q is E, so we are having potential, positive potential V. So due to the excess of energy, it is converting into kinetic energy due to this potential V. So what if we apply negative potential to this substance? Then the emission of electrons will be stopped. So the assertion here is correct, right? So let us move to the reason. Is he telling the correct reason or not? A negative electric potential which stops the emission of electrons from the surface of photoemissive substance varies linearly with frequency of incident radiation. Yes, right, it is correct, right? Suppose I have taken this as y-axis, y equal to, this is something constant and this is mx. The slope is m, that is e, and x is v plus something constant, this is h nu naught. So it is varying linearly with frequency of incident radiation. This is correct, right? Because see, it is linearly varying with frequency. Frequency is mu. So both reason and assertion are correct. But is the reason correct explanation for assertion? Once see it carefully. A negative electronic potential which stops the emission of electrons from surface of atomic substance varies linearly with frequency of incident radiation. Correct, right? Because this is varying linearly with frequency of incident radiation. So both A and R are correct. R is the correct explanation of A. So here he is telling that it varies linearly with frequency, but he is not explaining the assertion. Okay, so the correct option will be option number 4. Both A and R are true, but R is not the correct explanation of A. So let us move on to the next question, which is question number 36. The fractional compression delta V by V of water at the depth of 2.5 km below the sea level is dash percentage. Given the bulk modulus of water equal to 2 into 10 power 9 Newton per meter square, density of water equal to 10 cube kg per meter cube, gravity 10 meter per second square. So what he was asking, fractional compression. We knew the relation between bulk modulus and fractional compression. What is it? P equal to minus of P external by fractional compression. I hope everyone knows this relation, right? And they also have given the depth to us. What is the depth? Depth D equal to 2.5 kilometers, that is 2.5 into 10 cube meters. So here the P external is water is exerting the pressure, right, below the sea level. So the P external we can write as rho GH, that is 10 cube into 10 into 2.5 into 10 cube, right? So delta V by V equal to negative of P external is 2.5 into 10 power 3367 upon bulk modulus we have 2 into 10 power 9, that is 1.25 into 10 power minus 2. So he was asking in percentage, right? So when it is percentage, we will be multiplying with 100. So we are getting 1.25 percentage. So you might be wondering where will this negative has gone. So the negative has gone because it is delta V, right? It might be negative. Let us move to the next question, which is also assertion reason type. So the question is telling in assertion that is time period of a simple pendulum is longer at the top of a mountain than the top at the base of mountain. Is it correct? See, the time period of a simple pendulum formula is given as t equal to 2 pi root over L by G. Time period is longer when gravitational is decreasing. At mountain, what happens is H will decrease. So the time period of a simple pendulum will increase. So the assertion is right. So let us see, is the reason correct or not. Time period of a simple pendulum decreases with increasing value of acceleration due to gravity and vice versa. Yes, it is true, because if G increases, time period will decrease. So both A and R are correct, and R is the correct explanation of A, which is option number 1. So let us move to the question number 38. Consider a long straight wire of a circular cross section, let us say carrying a steady current I. The current is uniformly distributed across this cross section. The distances from the center of the wire's cross section at which the magnetic field inside the wire, outside the wire is half of the maximum possible magnetic field anywhere due to wire will be. Let us first understand the question. He was asking long straight wire is carrying a current of radius A. He was asking at which point we will get half of the maximum possible magnetic field anywhere due to the wire. That means inside there will be one point as such and outside there will be one point as such. So if we take any radius other than A, like x, which is less than A, the current enclosed by this long straight wire is I by pi a square into pi x square, that is I x square by a square. We knew the magnetic field due to a straight wire, that is B equal to mu naught I by 2 pi r. So B inside will be mu naught I enclosed, this is 2 pi something x, 2 pi x into I enclosed I x square by a square, that is mu naught I x upon 2 pi a square. This is P inside. Now B outside is having full current, right? B outside will be having full current, so B out equal to mu naught I by 2 pi r. So here you can observe B in is proportional to x, whereas B out is inversely proportional to x. That means like the graph is coming out like this. This is for a uniform long straight wire carrying a current. So they were asking not maximum. Maximum will be at r, that everyone knows. But they are asking B max by 2. So the maximum will be r and it is proportional to x inside the current straight wire. So the B max by 2 will be at x equal to r by 2, which is a by 2 according to question, right? And outside it is inversely proportional to x. So we are having mu naught I by 2 pi r into 1 by 2 equal to mu naught I into 2 pi x. So here when you compare x is, we are getting 2 into radius, which is x equal to 2a according to this question. So the points are a by 2 comma 2a, which is in the option 1. So students, let us move to the next question, which is question number 39, which is saying a body of mass m connected to a massless and unstretchable string goes in a vertical circle of radius r and a gravity g, like this. The other end of the string is fixed at the center of the circle. Let us assume it as c. If velocity at the top of circular path is n root gr, they are already given velocity at top of circular path n root gr. So they are asking ratio of kinetic energy of bottom to that at top of the circle is. So we already knew kinetic energy at top, right, which is half m n square gr into m. So what we want right now is kinetic energy at bottom. So we knew that initial kinetic energy plus work done by external forces plus negative work done also will come equal to final kinetic energy for a body by work energy theorem. So we want initial kinetic energy. So in case if you observe this path, it is moving upward but the gravity is downward. So work done by gravity in this process will be negative. So let us assume the initial velocity of this body is u. So half mu square minus, because the velocity of body is upward but the gravity is downward, minus mg into distance travel is r plus r 2r equal to final kinetic energy half mv square. So half mu square equal to half m square, we already knew that, half n square gr plus 2 mgr. So we are having initial kinetic energy as well as final kinetic energy. So let us take out the ratio. Kinetic energy bottom, kinetic energy top. What means half mn square gr plus 2 mgr upon half mn square gr. Cancel outing the common terms, we are left with n square plus 4 upon n square, because we are having 2 into 2, 4, right? So which is given in the option number 2. Okay, so students, let us move to the next question, which is question number 41. It is another assertion or reason type question. So the assertion tells that choke coil is simply a coil having a large inductance but a small resistance. Choke coils are used with fluorescent mercury tube fittings. If household electric power is directly connected to a mercury tube, the tube will be damaged. So nowadays every tube light is changed into LED, but before some 6-7 years, there were used to be fluorescent tube lights like this. So inside this glass tube, you will be having mercury, right? So you will also find on this tube there will be here a rectangular box like this, and at the same time a cylindrical one like this. So I am bad at drawing. So if you see, this is known as choke coil, right? This choke coil is having very large inductance. You know what is inductor, right? It resists sudden change in current, right? V equal to L into di upon dt. So what happens actually is, let me tell you detailedly. In the tube lights, mercury tube lights, we will be having very high voltage. We will be having very high voltage to evaporize these mercury particles inside this tube light. So we are having very high voltage to vaporize these mercury particles inside tube, so that they emit radiation in visible light. I hope you are understanding my point. So we need high voltage. So what is inductor or choke coil is doing in this process is, it is supplying high voltage to to these terminals so that mercury atoms will vaporize and they emit light in a lambda having visible light range. So let us see the reason. By using choke coil, the voltage across the tube is reduced by a factor r by root over r square plus omega square L square, where omega is frequency of supply across resistor star R and nectar L. If the choke coil were not used, the voltage across the resistor would be same as supplied voltage and it will damage the tube light. So we definitely need choke coil in fluorescent tube light. So both A and R are correct and R is the correct explanation of A. So which is obviously option number 4, right? Let us move to the next basic question, which is question 44. The expression given below shows the variation of velocity v with time t. So we are having this equation v equal to at square plus bt by c plus t. So time is having addition with c. That means c also must and should have the dimensions of time, and at square should have dimensions of velocity, that is lt inverse. So we are having a dimensions as l t power minus 3 and b into t. This is also time in case if you observe. Either should have velocity dimensions. That means we are having dimensions of b as same as velocity dimensions. He was asking ABC dimensions. L square t power minus 4 plus 1 t power minus 3, which is option number 4, right? So the next question, question number 45, is also a basic question, which is like this. For the circuit shown above, equivalent gate is. You can solve this problem by two ways: directly by mathematical reasoning or by general method, like me explain you in general way. So the first basic values, let us take 0 and 0. So there are two NAND gates and one NOR gate. So 0 and 0 for this NAND gate will give, let us take that output 1 will give 0 and 0. Actually AND gate 0, this is NAND gate which will give 1, and the output 2 will give, this is 0, this is 0. OR gate actually should give 0, but this is NOR gate, it will give 1, and this 1 and 1 will go to another NAND gate which is giving us the final output 1 and 1. Actually it has to 1, but this is NAND, so it will give 0. Next 0 and 1. 0 and 1 for NAND gate, it will give what? It will give 0. Here OR 0 and 1 should give 1, but this is NOR, so it will give 0 again. Again 0 and 0, it has to give 0, but this is NAND, it will give 1. So same applies. Same, you can observe G1 and another one is 0. 1 and 0 will give 0 for NAND, 1 and 0 will give 0 for NOR, and again 0 0, it will give 1. And the last case 1 and 1. 1 and 1 for NAND gate, it will give 0. 1 and 1 for NOR gate, it will give 0, and again 0 and 0 will give the final output 1. So only observe these A, B and final output 0 0 0, 0 1 1, 1 0 1, 1 1 1. So it is equivalent to a OR gate. So it was given in the option number 2. Let us move to the integer section and physics. The maximum speed of a boat in still water is 27 km per hour. Now This boat is moving downstream in a river flowing at 9 km per hour. So this is a river. If the boat is in still water, it can have speed to 27 km per hour. Now this boat is moving in downstream. That means like this, and it is having 9 km per hour. A man in a boat throws a ball vertically upwards with speed 10 meter per second. Vertically upwards with speed 10 meter per second. See, I am converting kilometer per hour into meter per second into 5 by 18, right? 15 by 2, 7.5 meter per second. Still boat, and it's 9 km per hour. This is 2.5 meter per second, right? So now they are asking range of the ball as observed by an observer at rest on the river bank is. So we are having an observer at river bank. He's rest. See, the ball is having 10 meter per second with respect to boat, but the boat is also moving already with 7.5 plus 2.5, that is 10 meter per second in horizontal direction. Why I am adding 7.5 plus 2.5? Because the boat is traveling in downstream in river. So this is according to ground. So the range will be horizontal velocity component into time of flight. So the horizontal component of velocity is 10 and time of flight is 2 into vertical velocity component v by g. So 2 into 10 by 10. So we are getting 20 meters range for this ball with respect to observer in the river bank who is at rest. But he was asking in centimeters. So 1 meter equal to 100 centimeters. We are having 2000 centimeters is the final answer. Let us move to the next question, question number 47, which is like this. A container of fixed volume contains a gas at 27 degrees. To double the pressure of the gas, the temperature of gas should be raised to. Very, very basic question, boards level question. So we are having fixed volume at 27 degrees Celsius, that equal to 300 Kelvin. So we need to pressure the gas. We know at fixed volume, pressure and temperature are directly proportional. So P1 by P2 equal to T1 by T2. And here he has given P2 equal to 2P1. So substituting in this, 1 by 2 equal to 300 by T2. So we are getting the final temperature as 600 Kelvin. That's all, very simple. But he was asked the answer in degree Celsius. It will be 600 minus 273, that is 327 degree Celsius, right? So that's the final answer. Let us move on to the next question, question number 48. The coordinates of a particle with respect to origin in a given reference frame is 111 meters. If a force of F bar equal to I cap minus J cap plus K cap acts on the particle, the magnitude of torque with respect to origin in Z direction is, which is a very basic level question. Everyone knows a formula for a torque, which is torque equal to R cap cross F cap. Very simple, right? So just calculate the depth for this. R cap you have given with respect to origin 1 1 1, F cap 1 minus 1 1. So just make sure you're right, doing right calculations. 1 minus of minus 1 minus J, 1 minus 1 0 plus K minus 1 minus 1 minus 2. So this is 2y minus 2k. So he was asking magnitude of torque with respect to horizon in z direction only, specifically asked only for z direction. So for z direction it is -2, but he was only magnitude, so which is 2. 49 telling like two light beams fall on a transparent material block at point 1 and 2 with angle theta 1 and theta 2 respectively as shown in figure. After refraction, the beams intersect at point 3, which is exactly on the interface at the other end. Here you can see. Given the distance between 1 and 2 equal to 4 root 3 centimeters and theta 1 equal to theta 2 equal to cos inverse n2 by 2 and 1, where refractive index of block 2 greater than block outside medium n1. Then he was asking the thickness of the block. See, it is very simple question, right? See, nothing is there in this. Suppose this is normal for first line, this is ray number 1, and it is subtending an angle theta 1 with surface, not with normal. Please make sure you are seeing this carefully. So because this n2 is greater than 1, refraction will take place at this point and it will move closer to the normal and it will join at point 3. See, here is given the beams intersect at point 3. Same happens with ray 2, which is subtending angle theta 2. It is also moving towards the normal, right? I am assuming this angle as alpha 1 and this angle as alpha 2. So from Snell's law we knew mu1 sine theta 1. See, this theta 1 is in Snell's law is with respect to normal. So with respect to normal it is subtending an angle 90 minus theta 1 equal to mu2 sine alpha 1. See, I am assuming alpha 1 with respect to normal only. So mu1 is initial medium, where it was in n1 outside medium. So n1 cos theta 1 equal to mu2, it is in n2 sine alpha 1, right? So we are focusing on sine alpha 1 to get the thickness of the block. Let us assume the thickness of block equal to t. See, so sine alpha 1 equal to n1 by n2 and cos theta 1. Similarly, same happens with the what? Same happens with the second ray also. So sine alpha 2 equal to, I am writing directly, I hope you will understand, n1 by n2 to cos theta 2. So in the question it was given theta 1 equal to theta 2. You can see here. So sine alpha is nothing but what? Let us assume this distance as A and this distance as B. So sine alpha 1 is A by thickness T, right? See, observe carefully. This is subtending angle 90. And sine alpha 2 is B by T. Sine alpha opposite by hypotenuse. Hypotenuse. Okay, sorry. It is hypotenuse. So B by hypotenuse. Right? Okay. But we need thickness of slab. So in case if you observe carefully, since theta 1 equal to theta 2, that means sine alpha 1 equal to sine alpha 2. Because we don't know hypotenuse, right? How can we know the thickness of slab? So since sine alpha 1 equal to sine alpha 2, we are also having tan alpha 1 equal to tan alpha 2, right? What is tan alpha? A by thickness of slab, A by T. And what is tan alpha T? Alpha 2, B by thickness of slab. We knew, in case if you observe, it was given in the question, the distance between 1 and 2 points is D. So A plus B equal to D, which is 4 root 3 centimeters. if I assume this K, A equal to KT plus equal to B equal to KT, 2 KT equal to 4 root 3. We don't know this K, right? Again, okay, leave it like this. So sin alpha 1 we have n1 by n2 into cos theta 1, which is n2 by 2n1. Okay, so alpha 1 we are sin alpha 1 we are getting as 1 by 2. That means alpha 1 equal to 30 degrees. Okay, alpha 1 is 30 degrees, ma. So we will then simply get relation a by t equal to what? Tan alpha 1. Tan alpha 1 is tan 30 degrees. Tan 30 degrees 1 by root 3. So a equal to t by root 3. So 2t by root 3 equal to 4 root 3. So here you will get t equal to 236 6 centimeters as thickness of slab. Okay, so let us move to the next question, question number 50, which is given as in a hydraulic lift the surface area of the input piston is 6 centimeters square and that of output piston is 1500 centimeters square. That means it is related to hydraulic lift. Okay, leave it, my drawing is bad. So let us take A1 as input piston, which is 6 centimeters square, A2 as output piston, which is 1500 centimeters square. We know that efficiency in a hydraulic lift is always 100%. That means whatever the pressure you are giving input, it will exerted at output. That means P1 equal to P2, that implies F1 by A1 equal to F2 by A2. We knew F1, which is given 100 Newton by input area 6 centimeters square. We need to find out F2 by area 1500 centimeters square, 3 table. So we are getting F2 as 25, 50, right? 50 into 5000, 25 into 10 cube Newton, 25 kilonewton. But he was asking work done to raise the output piston by 20 centimeters is. So work done equal to F dot D, right? So F we are having 25 into 10 cube. See, he was given as the distance as centimeters and asking us in kilojoules. So we have to convert centimeters into meters. 20 into 10 power minus 2. 10 cube, 10 power 4, 100. So we are getting 5000 joules, but the question he was asking in kilojoules, which is 5 kilojoules. Okay. Let us move to the next question, which is question